Our universe hides structures so vast and strange they defy physics itself. We are about to journey to the edge of the known cosmos to explore 25 of its most profound mysteries, colossal formations that remain forever out of our physical reach. By the end, you will understand the fundamental rules of reality that these cosmic giants are breaking. We will confront a void so enormous it should not exist, and a mysterious force pulling thousands of galaxies toward an unseen destination. What cosmic secret most challenges your view of the universe, this emptiness, is known as the Boots Void. Picture the universe not as a uniform sea of stars, but as a vast cosmic web, a sprawling network of brilliant galaxy filaments. The Boots Void is a gaping spherical hole torn in that web, a region of near total nothingness so immense it defies comfortable understanding. Stretching nearly 330 million light-years across, this void contains almost no galaxies. If our Milky Way resided at its center, we would not have known other galaxies existed until the 1960s. The sheer scale of this emptiness is what shatters our cosmological models. According to our best understanding of the Big Bang and the distribution of matter, a void this large should simply not exist. Matter should be more evenly spread, not gathered into one region while abandoning another of such staggering proportions. So how could such a desert form? One leading theory suggests it is a natural cosmic bubble, the result of smaller voids merging over billions of years into one ultimate emptiness. Another, more speculative idea proposes it could be evidence of an advanced civilization, a Kardashev Type 3 civilization that has harnessed the energy of entire galaxies, perhaps leaving behind a dark, engineered structure. While this is a fascinating thought, most scientists lean toward natural, if poorly understood, processes. The true terror of the Boots Void is not what might be there, but what is not. Its profound emptiness stands as a permanent challenge, a silent rebuke to our assumptions about a uniform cosmos. It forces us to ask if our sample of the universe is just a tiny, unrepresentative corner. What other impossibly vast structures are waiting in the darkness, ready to rewrite the rules we think are set in stone? This profound emptiness is not the only force guiding our cosmic journey. Our own Milky Way galaxy is caught in a relentless river of motion, pulled by an unseen hand. We are racing toward a mysterious region of space known as the Great Attractor at a staggering 14 million miles per hour. This is not just our fate. Thousands of other galaxies are flowing with us in a vast, intergalactic current toward this single point. The Great Attractor is a gravitational anomaly of almost unimaginable power, a focal point where the fabric of space itself seems to be gathering matter. But for decades, its true nature remained one of the universe's best-kept secrets, hidden behind a cosmic curtain. This curtain is called the Zone of Avoidance, a region of the sky obscured by the dense gas, dust, and brilliant stars of our own galaxy's central bulge. It is like trying to see a distant city through a thick, permanent fog. Our most powerful telescopes, designed to peer into the deepest cosmos, were blinded in this precise direction. How do you study the very thing you cannot see? Astronomers had to become cosmic detectives, using indirect methods. They meticulously mapped the peculiar velocities of galaxies, tracing the flow of this cosmic river backward to its hidden source. Each galaxy's movement was a clue pointing toward the gravitational heart of the Great Attractor. When technology finally advanced, allowing us to peer through the galactic fog with X-ray and infrared eyes, a surprising truth was revealed. The Great Attractor was not a single, monstrous object. It is an immense concentration of mass, a colossal supercluster of galaxies, many of which were hidden from our view. This discovery solved one part of the puzzle, but it also deepened the mystery. The sheer weight of the Norma cluster, a dense knot of galaxies at the core, and the surrounding vast collection of matter, is immense, but is it enough to account for the tremendous pull we feel? Some scientists now suspect the Great Attractor is merely a waypoint on a much longer, more terrifying cosmic journey, a tributary flowing into an even vaster and more powerful current. What could possibly be massive enough to command such a flow? That hidden current pulling us toward the Great Attractor is just one thread in the universe's largest tapestry. Far beyond our local flow lies a structure of such immense proportions that its very existence threatens to break a fundamental rule of cosmology. This is the Hercules-Corona Borealis Great Wall, the single largest known structure in the entire observable universe. To grasp its scale, you must first understand that for decades, cosmologists operated on a principle of mediocrity. They believed that on the largest scales, the universe was essentially smooth and homogeneous. Matter would be distributed fairly evenly, so that any two enormous volumes of space, billions of light years apart, would look roughly the same. The Hercules-Corona Borealis Great Wall shatters that assumption completely. It is a colossal filament of galaxies, a thread in the cosmic web so vast it stretches for over 10 billion light years. That means light, the fastest thing in the universe, would need more than half the age of the cosmos just to travel from one end of this structure to the other. We are not looking at a cluster or a supercluster, but a continent of galaxies, a wall that makes every other known formation seem tiny by comparison. How could we possibly discover something so unimaginably large? We cannot see it directly with optical telescopes. Its discovery was a masterpiece of cosmic deduction, revealed not by starlight, but by death. Astronomers use the most violent explosions in the universe, gamma-ray bursts, as their guide. These bursts are the final, catastrophic screams of massive stars collapsing into black holes, and they are so brilliant they can be seen across the universe. By mapping the locations of thousands of these bursts, scientists noticed an astonishing pattern. A stunning number of them were concentrated in a specific region of the sky, tracing the outline of this previously invisible, gargantuan wall of galaxies. Each brilliant flash was like a pin on a cosmic map, and when they connected the dots, the shape of a leviathan emerged. This discovery plunged cosmology into a profound crisis. The cosmological principle, a cornerstone of modern physics, states that the universe should look the same in all directions when viewed on a sufficiently large scale. But the Hercules-Corona Borealis Great Wall is far, far larger than what this principle deems possible. It is not a minor fluctuation. It is a glaring irregularity, a mountain range in what was supposed to be a flat and featureless plain. If the universe is not smooth and uniform at its grandest scales, then our entire understanding of its origin and evolution, rooted in the Big Bang Theory, may be incomplete. We are forced to confront a terrifying possibility. What if the cosmic structures we have already found are not the exceptions, but the rule? What if the universe is littered with such impossible giants, and we are only just beginning to see the true, uneven shape of reality? The universe's largest structures seem to break its fundamental rules, but some of its most beautiful formations challenge our understanding of cosmic creation on a more intimate scale. Drifting in the vast expanse is a galaxy so perfectly formed it appears almost artificial. Known as Hoag's object, It is a cosmic donut of staggering symmetry, a brilliant yellow core of ancient stars encircled by a flawless, vibrant blue ring of youthful stellar nurseries. Between them lies a gap so profound and dark, it seems to sever the two stellar populations completely. How could a galaxy evolve into such a pristine, isolated ring? The most intuitive explanation, a galactic collision, struggles to account for its perfection. When two galaxies collide, they typically create messy, distorted rings full of chaotic streams of stars, not this clean, detached circle. The ring of Hoag's object is almost perfectly circular and centered on the core, with no visible bridge of stars or gas connecting the two parts. It floats in space as a perfect whole, a cosmic bullseye that defies simple explanation. One compelling theory suggests this magnificent ring could be the result of a galactic merger that occurred in the distant past, so long ago that all the chaotic evidence has settled into this state of serene equilibrium. Another, more exotic idea proposes that a gravitational instability, a wave of density that swept through the original galaxy, could have triggered star formation only in a specific ring, leaving the core untouched and the central regions barren. Yet neither theory fully explains the immaculate symmetry and the sheer emptiness of the gap. It stands as a single, perfect question mark in the heavens, a reminder that the universe possesses not only immense power, but also an inexplicable sense of order. Could such perfection be a fleeting moment in a galaxy's life, or a sign of physical processes we have yet to even imagine? Yet the universe seems to specialize in building the impossible. Before we ever glimpsed the Hercules-Corona Borealis Great Wall, another discovery first rattled our confidence in a uniform cosmos, a structure called the Sloan Great Wall. This colossal filament of galaxies, stretching for an astonishing 1.37 billion light-years, was mapped in stunning detail by the Sloan Digital Sky Survey, a monumental project that methodically cataloged the heavens. For a time, it held the title of the largest known structure in the universe, a sprawling cosmic continent of interconnected superclusters that seemed to push the very limits of what was physically possible. Its discovery was a triumph of modern astronomy, revealing the intricate architecture of the cosmic web in unprecedented detail. But this triumph came with a profound unease. The Sloan Great Wall is not merely big, it is problematically big. Its sheer scale challenges a foundational idea in cosmology known as the cosmological principle, which suggests that on the largest scales, the universe should be homogeneous and isotropic, meaning it should look roughly the same in every direction and from every location. A structure of this length, a thread of concentrated matter so vast, is a glaring irregularity in what should be a smooth and featureless cosmic fabric. It is like finding a single mountain range that spans an entire continent on Earth, defying all expectations of the landscape. How could gravity have assembled something so immense within the lifetime of the universe? The processes that form galaxies and pull them into clusters and filaments are thought to have a natural size limit, a theoretical maximum beyond which structures should not have had time to coalesce. The Sloan Great Wall appears to brush against, or even surpass, that very limit. Its existence forces a difficult question upon us. Is this wall a rare statistical fluke, a 1 in a trillion chance that we just happen to find? Or is it a sign that our understanding of the universe's initial conditions and the growth of structure is fundamentally flawed? If such giants can form, then the cosmos may be far more textured and lumpy on its grandest scales than we ever dared to believe, hinting at a reality where the largest structures are not merely collections of matter, but active architects of cosmic destiny. Even the largest walls cannot contain the movement of the cosmos. Astronomers have detected a motion so strange, it defies all local explanation, a ghostly current named the dark flow. Across the universe, entire clusters of galaxies are drifting in a coherent stream, as if pulled by a gravitational hand that lies beyond the edge of everything we can see. This is not the local tug of the Great Attractor, but a vast, sweeping motion on a scale that should be impossible. The evidence for this mysterious flow comes from the oldest light in existence, the cosmic microwave background. This afterglow of the Big Bang serves as a perfect cosmic reference frame, a backdrop against which all other motions can be measured. By studying tiny temperature variations in this ancient light as it passes through moving galaxy clusters, scientists can detect a subtle shift, a Doppler effect that reveals the cluster's velocity. When they mapped these motions, they found something astonishing. Hundreds of clusters, scattered across billions of light years, were all moving in the same direction, at speeds of over 1 million miles per hour, toward a single point in space. This should not be happening. The combined gravitational pull of all the matter in our observable universe is not nearly strong enough to cause such a coordinated motion. The only plausible explanation is as unsettling as it is thrilling. Something immense, something lying far beyond the cosmic horizon of our observable universe, is exerting a gravitational pull on us. This suggests that the structure of reality is far grander than we thought. What could possibly have such power? It could be the gravitational influence of another universe entirely, a neighboring bubble in a vast multiverse, whose mass is tugging on the fabric of our own cosmos. Or it could be a remnant of the violent, inflationary expansion of the Big Bang, a cosmic texture or defect in space-time itself that is still driving this epic drift. The implications are staggering. If the dark flow is real, it is our first empirical hint that our universe is not alone, that we are just one island in an infinite archipelago of realities. This controversial phenomenon forces us to ask, what unimaginable structures lie in the unobservable beyond, silently steering the course of galaxies on a journey we can only begin to trace? The very uniformity of our cosmos is now under direct assault. Just 2 years ago, astronomers identified a formation so vast and so unexpected, it has been named simply the Giant Arc. This structure is not a wall or a filament, but a graceful, symmetric curve of galaxies, galaxy clusters, and intervening gas, stretching across an incomprehensible 3.3 billion light-years of space. To visualize this, picture a crescent spanning a full 15th of the observable universe, a bow of cosmic matter so immense it should be statistically impossible. Its discovery was not the result of looking for something new, but of re-examining what we thought we already knew. Researchers were analyzing the light from distant quasars, the brilliant cores of active galaxies, when they noticed a strange, consistent pattern. The giant clouds of magnesium gas drifting between us and those quasars were not randomly scattered. Instead, they traced a distinct, colossal archway across the sky, a structure that had been invisible until we learned how to see it. And its existence is a direct, brazen challenge to the cosmological principle. This foundational rule of cosmology insists the universe should be smooth and featureless at its grandest scales. But a 3.3 billion light-year-long arc is neither smooth nor featureless. It is a glaring, monumental wrinkle in the fabric of reality. The giant arc forces a difficult question. Is it a bizarre, one-in-a-million fluke, a chance alignment that just looks like a structure from our particular viewpoint? Or is it a sign that our most basic assumptions about the universe are fundamentally wrong? If such colossal structures can form, then the universe may be far more textured, more organized, and more strangely beautiful than our theories have ever allowed. What other impossible shapes are waiting to be drawn? Connecting the dots of the cosmos into a map we are only beginning to read. But even these grand arcs of matter are not the only luminous giants haunting deep space. Scattered across the cosmos are enigmatic, glowing behemoths known as Lyman alpha blobs. These are not compact galaxies or sharp points of light, but vast, diffuse clouds of primordial hydrogen gas, each one spanning hundreds of thousands of light years. They are cosmic ghosts, immense and faintly glowing with a very specific hue of ultraviolet light, a signature known as Lyman alpha radiation. These blobs are some of the largest individual objects in the entire universe, colossal clouds that often serve as the raw material and the birthing grounds for entire clusters of galaxies. Within their glowing hearts, stars and galaxies are being forged at a ferocious rate, lighting up the surrounding gas like a cosmic street lamp, illuminating a foggy night. Yet the central mystery of these blobs is not their size, but their light. What powerful engine could possibly make such a diffuse cloud of simple hydrogen shine so brightly across such an immense volume of space? The leading theories point to two incredible sources. The first is a frenzy of star formation, where millions of new stars ignite at once, their intense ultraviolet radiation energizing the entire cloud. The second is even more dramatic, the presence of a supermassive black hole at the cloud's core, its voracious appetite generating vast amounts of energy that heats the gas and causes it to radiate. Or perhaps it is a combination of both, a feedback loop of creation and destruction on an epic scale. These glowing blobs represent a crucial, fleeting phase in the life of the cosmos, a moment when the raw stuff of the universe collapses under its own gravity to build the grand structures we see today. They are the glowing embryos of future galaxy clusters, and their intense, mysterious light holds the secrets to how the largest things in the universe are born. What other colossal, glowing forms are waiting to be discovered, hidden in the faint background glow of creation itself? This ancient light holds another, more personal chill. Woven into the warm glow of the cosmic microwave background is a mysterious cold spot, a region of space significantly cooler than its surroundings. This is not a minor temperature fluctuation. The cold spot is a vast and profound anomaly, a cosmic bruise on the oldest visible surface of our universe. If it were a real void in space, it would have to be so unimaginably empty and enormous that its existence would itself defy our models of cosmic structure. The standard explanation points to a supervoid, a tremendous bubble of nothingness that the light from the Big Bang had to traverse. As light climbs out of a gravitational well, it loses energy, stretching into longer, redder, and cooler wavelengths, a phenomenon known as the integrated Sachs-Wolf effect. In this scenario, the cold spot is a shadow, a fossil imprint of light, struggling across a billion light-year-wide emptiness. Yet many scientists find this explanation unsatisfying. The required supervoid would be of such an extreme scale that it seems almost as unlikely as the cold spot itself. This has opened the door to a far more exotic possibility, one that reaches beyond our single universe. Some theorists propose that the cold spot is the scar of a cosmic collision, an imprint from a time when our budding universe bumped into another bubble universe in the vast multiverse. In this breathtaking hypothesis, the energy of that long-ago collision was siphoned away, leaving behind a cooler, quieter patch in our cosmic background. The debate between these two ideas, the improbable supervoid and the revolutionary multiverse collision, is a perfect snapshot of modern cosmology itself. It is a struggle between refining our existing understanding of the cosmos and daring to tear it down completely in favor of a far grander reality. Is this cold patch merely a statistical oddity, or is it our first tangible piece of evidence that we are not alone in the greater metacosmos, a permanent mark left by a neighbor we can never otherwise see? Yet even the chaotic death of stars can produce structures of breathtaking precision. Drifting thousands of light years away is a celestial masterpiece known as the Red Rectangle Nebula. This is not a typical billowing cloud of gas. Through a powerful telescope, it appears as a stunning geometric form, a near-perfect X shape with distinct, ladder-like rungs of glowing material connecting its four quadrants. It looks less like a natural object and more like a piece of cosmic origami or a beacon constructed by some advanced intelligence. The secret to this impossible shape lies in the death throes of the central star. This is not a single star, but a binary system, two stars locked in a tight cosmic dance. As one of these stars reached the end of its life and began to shed its outer layers, the intense gravitational influence of its companion star did something extraordinary. It funneled the expelled gas and dust into two powerful opposing jets, shooting out from the poles of the dying system. We are not looking at a sphere of gas expanding evenly into space. Instead, we are seeing a dense, donut-shaped disk of dust encircling the stars, forcing the outflows to escape only from the top and bottom, creating two cone-shaped streams of material. From our distant vantage point, viewed directly from the side, these two cones create the perfect X shape that defines the nebula. But what about the latter rungs, the equally spaced bars of light that make it look so artificial? These are thought to be sonic booms in space, periodic expansions in the outflowing gas. Imagine waves of material being ejected in pulses, creating rings within the cones. As we look through these stacked rings, they appear to us as the rungs of a glowing cosmic ladder. The intense red color comes from a specific type of carbon-based molecule, known as polycyclic aromatic hydrocarbons, being illuminated by the dying stars. The red rectangle is a fleeting phenomenon, a beautiful and intricate phase that will last only a few thousand more years before the central stars heat up, causing the gas to glow as a more typical planetary nebula. It is a perfect reminder that even in stellar death, the universe operates with a hidden geometry, creating temporary works of art that challenge our very definition of natural form. What other perfectly shaped secrets are hiding in the final breaths of dying suns? Our galaxy is not alone in its quiet corner of space. It is the center of a delicate gravitational dance, and two of its most prominent partners are the Large and Small Magellanic Clouds, small satellite galaxies visible from the southern hemisphere. Yet these are not the full extent of these celestial companions. Trailing behind them for over 600,000 light years is a colossal, invisible river of gas known as the Magellanic Stream. This is not a structure you can see with an optical telescope. It is a ribbon of cold, neutral hydrogen gas, so vast it wraps around nearly half of our night sky. For decades, its origin was one of the great local mysteries of our galactic neighborhood. Where did this incredible trail of cosmic debris come from? The most compelling answer tells a story of gravitational theft and a slow-motion dismemberment that has been unfolding for billions of years. As the Magellanic Clouds have orbited our much larger Milky Way, our galaxy's immense gravitational pull has been relentlessly stripping them apart. The stream is the visible evidence of this tidal destruction, a wake of gas torn from the smaller galaxies and left to drift in their orbital path. But the story does not end there. This river of gas is now on a collision course with our own galaxy. In the far future, this entire stream of primordial material will spiral inward, eventually raining down upon the Milky Way's outer disk. This incoming fuel could one day trigger a new wave of star formation, seeding our galaxy with fresh stellar nurseries. The Magellanic Stream is a stunning example of a cosmic structure in motion, a temporary but immense bridge between galaxies that shows us the dynamic, and often violent, interactions that continuously shape the universe around us. What other invisible rivers of matter are flowing through the darkness, connecting galaxies in a web of creation and destruction we have only just begun to trace? Even our own seemingly quiet galaxy harbors explosive secrets on a colossal scale. Extending above and below the Milky Way's central bulge are two immense, ghostly orbs known as the Fermi bubbles. These are not structures of stars or gas in the traditional sense, but vast balloons of extremely hot, magnetized gas, each one towering 25,000 light-years from the galactic plane. If our eyes could see the high-energy gamma-ray light they emit, these twin spheres would dominate the sky, covering a region as large as 50 full moons. They remained completely hidden from us until just over a decade ago, when NASA Fermi Gamma Ray Space Telescope finally revealed their faint, energetic glow against the darkness. Their discovery immediately posed a monumental question. What cataclysmic event could have blown these perfect, symmetrical bubbles out from the very heart of our galaxy? The prime suspect resides at the exact center of this cosmic explosion, our own supermassive black hole, Sagittarius A star. While it is quiet today, the leading theory suggests that several million years ago, it experienced a ferocious feeding frenzy. As vast amounts of gas and dust spiraled into its event horizon, the black hole did not swallow all of it. Instead, it converted a portion of that incredible mass into energy, launching two opposing jets of superheated plasma from its poles at nearly the speed of light. These jets, punching through the galactic halo, would have inflated the colossal structures we now see as the Fermi bubbles. This would have been the most violent event in our galaxy's recent history, a brief but terrifying eruption that reshaped its very core. However, an alternative theory points to a different kind of cataclysm. Instead of a single black hole outburst, the bubbles could be the accumulated shockwaves from a period of intense star formation. In this scenario, the galactic center witnessed the birth and explosive death of hundreds of massive stars in a short period, their combined stellar winds and supernova blasts creating a powerful outflow that inflated the bubbles over a longer time. So, was it a single, deafening roar from the black hole, or a sustained, thunderous symphony of stellar death? The evidence is still being gathered, but the existence of the Fermi bubbles is a stark reminder that even a calm-looking galaxy like our own has a violent and explosive past. What other immense, invisible structures are we living inside, completely unaware of their presence and the ancient forces that sculpted them? This cosmic void is not a distant abstraction, but our immediate galactic neighborhood. We are floating inside the Kebasi void, a spherical cavity of relative emptiness so immense it spans 2 billion light-years. Our Milky Way and its local group of galaxies sit within this colossal bubble, a region of space that contains far fewer galaxies, clusters, and dark matter than the cosmic average. While not as utterly desolate as the Boots void, this local underdensity is a vast cosmic desert, and we are living in one of its few oases. The existence of this void around us creates a profound observational bias, a distortion in our view of the cosmos. When we measure the expansion rate of the universe, a value known as the Hubble constant, we assume we are in a fairly average place. But what if we are not? Living inside this giant bubble would mean that the gravitational tug of the denser matter outside our local void is subtly different than we expect. The space inside our underdense bubble expands a little faster than the more crowded space outside. This local speed boost could be tricking us into measuring a higher value for the Hubble constant than is true for the universe at large. This is not just a minor accounting error. It strikes at the heart of one of cosmology's greatest modern mysteries, the Hubble tension, where different methods of measuring the universe's expansion rate yield conflicting results. Could our place inside this vast emptiness be the key to resolving this conflict? Furthermore, the properties of dark energy, the mysterious force accelerating cosmic expansion, are also measured from our local vantage point. If we are in a giant hole, our calculations for the strength of dark energy might be slightly off. The KBC void forces a humbling realization. Our entire cosmic census, our most fundamental constants, are filtered through the lens of our atypical address. We are not impartial observers of the universe, but residents of a specific and strangely empty corner of it. What other foundational truths of cosmology might be skewed by the simple fact of where we happen to be? Hoag's object is not entirely alone in its perfection. Across the cosmos, other celestial rings echo its strange geometry, each one telling a different story of cosmic violence and rebirth. One of the most stunning is AM 0644741, often called the Lindsay-Shapley ring. This galaxy presents a breathtaking sight, a brilliant blue ring of newborn stars, some 311 light-years across, encircling a seemingly older, yellowish core. But the story here is far more dramatic than Hoag's serene mystery. The ring of AM 0644741 is almost certainly the result of a head-on galactic collision, a bullseye impact of staggering proportions. Billions of years ago, a smaller galaxy likely plunged straight through the heart of a larger disk galaxy. The gravitational shockwave from this collision would have sent powerful ripples through the larger galaxy's gas, much like a stone thrown into a pond. This ripple compressed the gas, triggering a ferocious wave of star formation that began at the point of impact and spread outward, leaving behind the luminous blue ring we see today. In this scenario, the core we observe is the surviving heart of the original disk galaxy, left relatively undisturbed as the shock wave moved through its outer reaches. This mechanism, known as a collisional ring galaxy, is a powerful and destructive way to forge such beauty, yet not all rings form from such chaos. Some may be born from a gentler, more persistent gravitational rhythm known as resonance. A galactic bar, a long central structure of stars found in many spiral galaxies, can create stable orbital resonances. These are regions where the gravitational tug of the bar synchronizes with the orbits of stars and gas, much like the consistent push on a swing makes it go higher. At certain resonant distances from the core, gas can be compressed and pile up, igniting star formation in a perfect circle, completely independent of any collision. This process can create a ring that appears detached, a perfect circle of stellar birth driven by the galaxy's own internal music. So why are these cosmic rings so exceptionally rare? Their formation requires a very specific and fleeting set of circumstances. A collisional ring needs a nearly perfect direct hit, a cosmic bullet fired with precision, and the resulting structure is transient, destined to fade as the brilliant new stars burn out and the ring dissipates over a few 100 million years. A resonance ring requires a galaxy with a strong, stable bar and just the right amount of gas to ignite. Hoag's object itself may be a relic of an ancient, fully settled merger, a ghost of a collision so old that all the evidence of the chaos has smoothed away into serene symmetry. Or it could be the product of a rare, stable resonance we do not yet fully understand. Their enduring mystery lies in this duality. They are both the scars of catastrophic violence and the signatures of delicate, persistent cosmic forces, leaving us to wonder if their perfect shapes are the last whispers of destruction or the first notes of a new, stable order. These vast rings and glowing arcs are all held together by an invisible hand. Every galaxy, from our own Milky Way to the most distant island universe, is embedded within a colossal sphere of a mysterious substance we call dark matter. This is not a structure you can ever see, but its gravitational signature is unmistakable. These dark matter halos form the true backbone of the cosmos, an unseen skeleton upon which all visible matter is draped. We know they are there because of the way galaxies spin. The stars on the outer edges of spiral galaxies orbit at the same incredible speed as those near the core. This defies all logic, like the outer horses on a merry-go-round somehow keeping perfect pace with the inner ones. According to the laws of gravity, these outer stars should be flung off into the void. The only explanation is that they are held in place by the immense gravitational pull of an enormous, invisible mass, a halo of dark matter that extends far beyond the galaxy's luminous edge. The evidence does not stop there. We can see these halos at work through gravitational lensing, where the gravity of a massive object, like a galaxy cluster, bends the light from more distant galaxies behind it, distorting their images into faint, beautiful arcs. The amount of bending we observe is far too great to be caused by the visible stars and gas alone. It reveals the presence of a deep, gravitational well carved out by a titanic halo of dark matter, a lens of pure gravity magnifying the distant cosmos. These halos are predicted to have a specific structure, denser at their centers and becoming more diffuse at their edges, with countless smaller subhalos swarming within them like invisible bees. Yet for all our certainty about their gravitational influence, we have no idea what dark matter actually is. It does not emit, absorb, or reflect any form of light. It seems to interact with normal matter only through gravity, passing through our planet, our homes, and even our bodies as if they were not even there. Is it a sea of exotic, undiscovered particles, left over from the Big Bang? Could it be primordial black holes, formed in the universe's first frantic moments? Or does its mystery point to a need to rewrite the laws of gravity themselves? This invisible architecture is the most dominant form of matter in the universe, the hidden framework that has guided the growth of every structure we have explored, and its true nature remains one of the most profound puzzles in all of physics. What would our universe look like if we could suddenly see this ghostly scaffolding in all its intricate, overwhelming detail? This slow-motion feast is happening right in our galactic backyard. The Great Andromeda Galaxy, our closest major neighbor and a beautiful spiral, is not the serene island it appears to be. It is a predator, actively consuming its smaller satellite galaxies in an act of cosmic cannibalism that is reshaping its own structure. We can see the evidence of these ancient meals strewn across the sky in the form of vast, faint streams of stars. These are stellar rivers, the torn-apart remains of dwarf galaxies that ventured too close to Andromeda's immense gravitational pull. Over billions of years, the relentless tidal forces have stretched these galaxies into long, arching ribbons, wrapping around Andromeda like celestial spaghetti. This process is not just about visible stars. It also involves the invisible dark matter halos that surrounded these ill-fated dwarfs. As the satellite galaxies are disrupted, their dark matter is also stripped away, forming diffuse, interwoven streams that contribute to Andromeda's own massive dark matter halo. This hierarchical formation, where large galaxies grow by consuming smaller ones, is a fundamental process in the universe. We see it echoed in our own Milky Way, which is also surrounded by the shredded remains of devoured satellites, like the Sagittarius dwarf galaxy. Andromeda's current feast gives us a front-row seat to this ongoing cosmic assembly. It is a living laboratory showing us how galaxies build themselves up over time, growing not just from the gas of the early universe, but from the stars and dark matter of their conquered neighbors. This violent history also points directly to our own future. The same gravitational dynamics that are tearing apart these dwarf galaxies are drawing Andromeda and the Milky Way toward each other on an inevitable collision course. In about 4.5 billion years, our two galaxies will begin their own epic merger, a titanic dance that will likely fling stars into new orbits, trigger colossal waves of star formation, and ultimately create a new, larger elliptical galaxy. The cannibal we observe today will one day become our partner in a union that will reshape the entire local group. What other stellar streams are we living alongside? The ghostly signatures of ancient galactic meals that have already taken place. The silent architecture of dark matter is shaken by the most violent outbursts imaginable. Deep within the Ophiuchus supercluster, a gathering of thousands of galaxies, lies the fossilized scar of the largest explosion ever recorded in our universe. This is not the aftermath of a star, but a supermassive black hole's tantrum of almost incomprehensible power. The evidence is a gargantuan cavity, a bubble carved out of the superhot plasma that permeates the space between galaxies in a cluster. This void in the scorching gas is 15 times the diameter of our entire Milky Way. To create such a hole required an energy release 5 times greater than the previous record holder. An event so colossal it is difficult to find the words. The force needed to blast this cavity is equivalent to detonating 20 billion megatons of TNT every second for 240 million years. It is a scale of energy that dwarfs every quasar and gamma ray burst we have ever catalogued. The prime suspect for this cosmic cataclysm is the supermassive black hole at the core of one of the supercluster's central galaxies. This is not a story of the black hole consuming matter, but of it violently rejecting it. As vast quantities of gas spiraled into the black hole's accretion disk, the immense magnetic fields and rotational energy generated powerful jets that shot out from its poles at near light speed. These jets did not simply dissipate. They acted like cosmic blowtorches, punching directly into the surrounding cluster plasma and forcing it aside to create this unimaginably large bubble. The eruption has long since ended, the jets have faded, and the black hole has returned to a slumbering state. What we observe today is the ghost of that eruption, a silent, expanding cavity that remains as a permanent monument to a brief era of unimaginable violence. This single event likely reshaped the entire future of star formation for thousands of galaxies in its vicinity, heating the galactic fuel and preventing new stars from being born. The Ophiuchus explosion forces a question about our own cosmic neighborhood. Could the Fermi bubbles above our own galaxy be the faint echo of a similar, though smaller, cataclysm that erupted from Sagittarius, a star millions of years ago? And if such an event can happen once, what prevents it from happening again on an even more terrifying scale? Sometimes the evidence for dark matter seems to vanish entirely. A cosmic stone's throw away, just 60 million light-years from Earth, lies the Fornax cluster, a dense gathering of galaxies that should be a textbook example of dark matter's dominant role. Yet within this cluster, astronomers have found galaxies that defy the textbook, galaxies that appear to have been stripped of their dark matter entirely. This discovery strikes at the very heart of our understanding of how the universe is built. How could a galaxy lose its invisible skeleton? The answer lies in the brutal environment of the cluster itself. Fornax is a crowded, violent place, with galaxies whipping past each other at incredible speeds, all bathed in a superheated plasma known as the intracluster medium. As a smaller galaxy falls into this dense environment for the first time, it experiences a cosmic ordeal. The intense gravitational pull from the cluster's collective mass tugs at the galaxy, while the searing heat of the plasma acts like a powerful headwind, physically pushing against the galaxy's own gas. Here is the crucial difference between dark matter and normal matter. The visible gas and dust in a galaxy feel this friction and can be ram pressure stripped away, like smoke being blown from a candle. But dark matter, which only interacts gravitationally, should be immune to this. It should simply pass through everything, remaining bound to its galaxy. Yet observations of certain galaxies, particularly diffuse dwarf galaxies in Fornax, show they have very little, if any, dark matter left in their vicinity. How is this possible? The leading theory is as elegant as it is violent. It suggests that the very act of falling into the cluster creates a gravitational slingshot effect. As a galaxy plunges in and swings around the dense core, the cluster's immense gravity can, through a complex tidal interaction, rip the dark matter halo away while leaving the more tightly bound stars relatively intact. The galaxy survives the journey, but arrives in the inner cluster stripped of its invisible shield, a ghost of its former self. This process, if confirmed, reveals a dynamic we never anticipated. Dark matter halos are not always permanent anchors. They can be torn off in cosmic collisions, leaving behind visible galaxies that float nearly naked in the void. This forces a profound revision of our models. It means the relationship between a galaxy and its dark matter is not always a fixed marriage, but can be a temporary alliance, broken by the unforgiving forces of the cosmos. What does this mean for the countless other galaxies living in similar dense urban environments? Are we seeing a common fate, or a rare cosmic crime scene? Our own galaxy holds a secret geometry that challenges our cosmic blueprints. Orbiting the Milky Way is a formation known as the vast polar structure, a colossal and thin plane of satellite galaxies, star clusters, and stellar streams that rotates in a precise, coherent disk. This structure is not aligned with the flat spiral of our galaxy, but stands at a near-perfect right angle to it, like a giant wheel slowly turning around a central hub. For decades, our best cosmological simulations predicted that the small satellite galaxies orbiting a giant like the Milky Way should be scattered randomly around it, a swarm of bees buzzing in a chaotic cloud. The existence of this vast, organized, and rotating plane defies that expectation completely. It is a configuration that our standard models of galaxy formation, which rely heavily on the gravitational influence of dark matter, struggle to produce. How could such a thin, coherent structure form and persist? One compelling and dramatic explanation points to a violent event in our galaxy's distant past. This immense polar disk could be the fossilized debris from a colossal collision, the torn-apart remains of a single, large satellite galaxy that was captured and shredded by the Milky Way's gravity billions of years ago. As this victim galaxy was pulled apart, its stars and dark matter would have been stretched into a vast stream that eventually settled into this stable, rotating plane. This would be a galactic merger on a scale far greater than any we see happening today. An alternative, and even more radical, idea suggests this structure might be a signature of the very nature of dark matter. If dark matter is not entirely cold and collisionless, but has some subtle, interactive properties, it could potentially form such thin, rotating disks on its own, pulling visible matter into this unexpected alignment. The vast polar structure is more than just a collection of orbiting objects. It is a ghostly imprint of a catastrophic ancient history, or a clue pointing toward a new understanding of the universe's invisible components. This precise, rotating wheel around our home forces us to wonder if the serene galaxy we see today is actually built upon the bones of a much more violent and dynamic past. Sometimes the universe writes its history in perfect circles. Far beyond our local superclusters, within the dense Zwicky cluster, astronomers have found a formation that seems almost too symmetrical to be real, a nearly perfect ring of galaxies. This is not a small arrangement. The circle spans a staggering distance, a cosmic hula hoop woven from entire galaxies. Its existence presents a puzzle on a grand scale, for such a flawless shape challenges our ideas of how the largest structures in the cosmos interact and evolve. The most compelling explanation for this ring is a story of colossal violence, a titanic collision between two massive galaxy clusters that occurred in the distant past. We are not witnessing a simple merger, but the aftermath of a head-on impact of almost unimaginable force. Picture the event not as a chaotic tangle, but as a stone dropped into a pond. When these two immense clusters smashed together, the shock wave would have propagated outward through the superheated plasma that fills the space between the galaxies. This powerful ripple, a wave of compressed gas and energy, swept through the cluster. The galaxies themselves, relatively unaffected by the gaseous friction, were left behind in the wake of this shockwave, much like leaves gathering on the surface of a receding wave in a pond. As the ripple expanded, it left the galaxies arranged along its leading edge, tracing a perfect, expanding circle in the sky. This elegant explanation, however, comes with profound implications. The ring's precise geometry suggests that the initial collision had to be remarkably straight and direct, a cosmic bullseye of rare precision. It also reveals that the dark matter halos of the two clusters, which make up the vast majority of their mass, likely passed right through one another during the impact, since dark matter does not interact with itself. The visible ring we see is just the luminous tracer of a much deeper gravitational event, a ghostly imprint of a shockwave that has long since faded from view. What other perfect shapes are scattered throughout the cosmos? The silent echoes of ancient collisions we have not yet learned to read. Our own galactic plane and its vast polar structure exist within a much grander sphere, the ultimate cosmic boundary we call the Hubble volume. This is not a physical edge, but the limit of our sight, a bubble of space 14.4 billion light-years in radius defined by how far light has been able to travel since the dawn of time. Everything we have ever seen, from the nearest star to the most distant quasar, from the Bootes void to the Hercules-Corona Borealis Great Wall, resides within this one observable sphere. Yet the universe almost certainly does not end at this horizon. The totality of reality, the unobservable universe, is likely unimaginably larger, perhaps even infinite. The theory of eternal inflation suggests that the Big Bang was not a single event, but one eruption in a forever expanding metacosmos, a frothing sea of spacetime where new bubble universes are constantly budding off, each with its own unique physical laws. Our entire Hubble volume, with all its galaxies and mysteries, might be just one bubble in this infinite cosmic foam. This idea of a multiverse carries staggering implications for the structures we have explored. The dark flow, that mysterious drift of galaxy clusters, could be the gravitational tug of a neighboring universe, a colossal structure in the next bubble over that we can never directly observe. The impossible scale of the giant arc or the Hercules-Corona Borealis Great Wall might not be flukes at all, but hints that our local patch of reality is just a small sample of a far grander and more varied cosmic geography. What kinds of structures could exist out there in the infinite beyond? There could be cosmic walls that make our Great Wall look like a tiny crack, voids so deep they contain not a single atom, or intricate celestial machines operating on scales that dwarf our entire observable universe. We are forever confined to our own Hubble volume, prisoners of light and time, able to theorize about the wonders beyond the curtain, but never able to lift it. This ultimate limitation forces a profound humility. The greatest cosmic structures may be the ones that are, by the fundamental laws of physics, forever beyond our reach. This cosmic web, the grand architecture we have been exploring, is locked in a silent war with an invisible force. Dark energy, the mysterious agent driving the universe's accelerating expansion, is not merely stretching the space between galaxies. It is fundamentally shaping the destiny of the cosmic web itself. You can picture this web as a vast, three-dimensional tapestry woven from gravity, with dense clusters of galaxies at the intersections, long filaments connecting them, and immense, empty voids in between. For billions of years, gravity has been the master architect, tirelessly pulling matter into these structures, building walls and nodes in an ongoing project of cosmic construction. Dark energy acts as a counterforce, a cosmic tension that works against gravity's pull. In the early universe, gravity reigned supreme, allowing these colossal filaments and clusters to form. But as the universe expanded and grew more diffuse, the relentless push of dark energy began to dominate. Its influence is not to build, but to unravel. It stretches the very fabric of spacetime, increasing the distances between the nodes of the web and thinning out the gossamer filaments that bind them together. Over trillions of years, this accelerating expansion will lead to a profoundly lonely future. Galaxy clusters, once bound together in vast superclusters, will become isolated islands, their gravitational connections severed as the space between them expands faster than any signal can cross. The filaments themselves will stretch and snap, disconnecting the cosmic web strand by strand. But what if this acceleration does not just isolate, but utterly destroys? This brings us to one of the most dramatic endpoints for the cosmos, the Big Rip scenario. In this hypothesis, dark energy does not merely accelerate, but grows stronger over time. If it possesses a specific, devastating property, its repulsive force could eventually overcome all other forces in the universe. It would first tear apart galaxy clusters, then individual galaxies. As the acceleration intensifies, It would rip stars from their galaxies and planets from their stars. In the final moments before time itself loses meaning, the fabric of space-time would tear apart, pulling apart atoms, atomic nuclei, and ultimately the very building blocks of matter. The cosmic web, the beautiful, intricate structure that took billions of years for gravity to build, would be utterly and completely shredded. While this is a speculative future, it highlights the immense power of dark energy. It is not a passive background energy, but an active participant in the story of the cosmos, an enigmatic force that built nothing we can see, yet holds the ultimate power to tear everything apart. The whispers of the ancient universe are not carried on light, but on radio waves. Scattered across the cosmos are the faded, ghostly remains of what were once the most powerful objects in existence, known as relic radio galaxies. These are the cosmic fossils of ferocious activity, the lingering radio lobes of active galactic nuclei that have long since fallen silent. Billions of years ago, the supermassive black hole at the heart of these galaxies was a raging beast, devouring matter and blasting out colossal jets of plasma at nearly the speed of light. These jets, stretching for millions of light years, filled enormous lobes with energetic particles and magnetic fields, causing them to glow brightly in radio frequencies. Then, the central engine shut down, the feeding frenzy ended, and the brilliant jets sputtered out. But the giant radio lobes did not simply vanish. Devoid of their power source, they have been slowly fading away for eons, like the dying embers of a colossal fire. We are now detecting them in their final stages of life, long after the central black hole has become quiet and dormant. These relics are more than just cosmic ghosts. They are historical records. By studying their size, shape, and faint emission, astronomers can piece together the life cycle of these galactic monsters. They tell us about the duration and intensity of past black hole eruptions, offering a glimpse into the violent conditions of the early universe. Each relic is a silent monument to an era of dramatic transformation, a time when the energy output of a single black hole could reshape entire galactic neighborhoods, heating surrounding gas and suppressing star formation across vast volumes of space. Why do some galaxies leave behind these magnificent fossils, while others fade without a trace? Their enduring presence challenges us to understand the final, quiet chapters in the lives of the universe's most energetic objects. A cosmic nursery glows with both creation and destruction. The Orion Nebula, a vast stellar maternity ward, is home to some of the most beautiful and violent scenes in the galaxy. Here, infant solar systems known as proplyds are being forged, while the very stars that illuminate them threaten to tear these potential cradles of life apart. A proplyd, short for protoplanetary disk, is a swirling, flattened cloud of gas and dust encircling a newborn star. Within this dense, rotating disk, the raw materials for planets are beginning to clump together, a delicate dance of accretion that could one day lead to rocky worlds and gas giants. The Orion Nebula is filled with these embryonic systems, offering us a front row seat to the birth of planets. Yet this nursery is far from serene. It is dominated by the Trapezium cluster, a group of brilliant, massive stars that burn hot and fast. These stellar titans unleash a torrent of intense ultraviolet radiation, a cosmic hurricane that scours the nebula. For the proplyds, this radiation is a double-edged sword. When this blistering starlight hits a proplyd, it does two opposing things simultaneously. It heats the outer layers of the gas disk, causing them to evaporate and stream away from the central star in a magnificent, glowing tail, like a comet soaring through interstellar space. This process sculpts the disk, revealing its intricate structure and allowing us to witness its beauty. But it also erodes it, stripping away the very material needed to form planets. This creates a dramatic race against time. Can the proplet form planets faster than the radiation boils it away? For some, the answer is no. The smallest and most vulnerable proplets, those closest to the massive stars, are being photoevaporated so quickly that they may lose their entire reservoir of gas and dust before planets can fully coalesce. Their potential for building new worlds is literally being blown into the void. Others, situated farther from the stellar inferno or shielded by thicker disks of their own dust, might survive the onslaught long enough for planetesimals to collide, stick together, and grow into full-fledged planets. Our own solar system may have formed in a similarly chaotic environment, a baptism of stellar fire that we somehow endured. The fate of each proplet is a cosmic gamble, a delicate balance between the creative force of gravity and the destructive power of starlight. How many potential Earths have been lost to such celestial storms? And how many others are forming right now, against all odds, in the turbulent heart of a glowing nebula? Our cosmic journey ends by looking inward, into the violent and mysterious heart of our own Milky Way. At its very center, governing the stately rotation of 400 billion stars, lies Sagittarius, a star, a supermassive black hole with a mass 4 million times that of our Sun. This is not a dark, empty pit, but a dynamic and chaotic arena where the laws of physics are pushed to their absolute limit. We cannot see the black hole itself, but we can witness its ferocious gravitational influence on everything that dares to approach it. Stars are whipped around it at breathtaking speeds, tracing elliptical orbits that reveal the immense, concentrated mass at the core. Yet some of the objects dancing around this cosmic monster are not stars at all. They are mysterious entities known as G-objects. From a distance, they look like compact clouds of gas, but as they swing close to the black hole on their long, looping orbits, they do not get torn apart. They stretch and contort, yet somehow hold themselves together, suggesting they may be stars hidden within thick, dusty cloaks of gas, or perhaps the merged product of two stars that collided in the violent environment. Their strange resilience is a testament to the bizarre conditions that exist only here. More recently, astronomers have been tracking another peculiar visitor, a gas cloud designated X7. This object has been stretching and elongating at a remarkable rate as it falls toward its inevitable doom. Over just 16 years of observation, X7 has more than doubled in length, pulled thin by the black hole's extreme tidal forces. It is likely a cloud of gas and dust that was stripped away from one of those larger G objects during a close pass, and it is now on a one-way trip, destined to be shredded and consumed, feeding the silent giant at our galaxy's core. This dynamic environment reveals a fundamental truth about galactic cores. They are not static points, but vibrant, evolving ecosystems governed by a single, supermassive black hole. The activity around Sagittarius, a star, from the strange G objects to the disintegrating X7 cloud, shows us how these central engines interact with and shape their immediate surroundings, influencing the very evolution of the galaxy they anchor. Our journey across the cosmos, from the largest walls to the smallest, most violent centers, demonstrates that every scale of the universe is interconnected, bound by gravity and mystery. Our journey across these 25 cosmic enigmas reveals a universe that is not merely vast, but deeply, fundamentally strange. The silent voids, the impossible walls, the ghostly flows, and the perfect rings all whisper a single, humbling truth. Our understanding of reality is not wrong, but it is profoundly incomplete. We are like explorers who have only just mapped the shoreline of an entire continent, unaware of the towering mountains and sweeping deserts that lie beyond the horizon. Each of these structures is a question written on a galactic scale, challenging the rules we thought were absolute and pushing the boundaries of science itself. They remind us that the cosmos is a place of endless wonder, where the greatest discoveries are likely still waiting, hidden in the darkness between the stars. This grand tour does not leave us with all the answers, but with something far more valuable, a renewed sense of curiosity and a deeper awe for our place in this magnificent, mysterious tapestry. The universe is not just a collection of objects to be catalogued, but a story to be unraveled, one that inspires us to keep looking up, to keep questioning, and to never stop marveling at the profound beauty of the unknown.